know who wants to participate in the exercise. And if everybody, all the professors are also participating, or no. And then we need to make teams. I need to count you, but I think maybe teams of 4 is more appropriate because then I have to go to less groups for help. That would be good. We don't want this.
Really try to change gold to lithium. This is now.
Gold is much rarer than lithium. Several others.
I see you are having the conversations with power. You are socializing with power.
So let's start with the finishing up of the last one. So the takeaways that we got from modeling William with the materials is it is possible to link economic units with physical units. The clear advantage is if you want to have an input-output table model that is in the economics, that you have like similar sectors of materials matching these sectors, because otherwise the separation is very, very difficult, because there's also groups like base metals or precious metal group. But it is really difficult for me to determine the size of the demand according to one particular metal from these kind of sectors. So the higher the sector separation in the material resolution, the better it is possible to link these units consistently. Results are realistic when we tested with the historical demand and the input data that I showed you. And so critical for functionality is the demand for energy and materials is within reasonable magnitude. So the models of the economic model and the energy model, they need to be calibrated so we are able to reproduce historic data from 2015 to 2022. And the model constraints mass balance equation that works. Like we tested this with increasing prices or with taking away certain parts of the supply, and that effect is visible in the model. So now I would like you to form groups. What you need, I will give you, I think, a bigger sheet because it's much easier when you want to draw your ideas, and you should do each task by task, and I want form groups of 4 people, maybe one group, or 2 groups with 5 people, depending who is participating or not. And then you should start with task 1, or like with part 1 of the task. I will give you each a sheet, and you should probably sit together. You don't need a laptop, you just need a pen and a paper. And then you do like the parts that yesterday Luis did for you guys on the table. Like on the blackboard or whiteboard in this case, you conceptualize. So what you do is basically what we did to build William. Like you read like a scientific article of the fairy tale of Snow White and this Gold's Empire, and then you extract the information and try to see how this information is linked to each other, and then you construct a resource model based on that. So the goal is like start really bit by bit, start with the simple, first task first, and then add more and more complexity. Before you start a new task, consult me and let's have a chat if you have all the links correctly, and if it is logical what you did. And maybe one group wants to present on the whiteboard in the end what they did and explain to the others why they think they have the correct resource model. And then we can maybe identify together the units and what are stocks and flows. If there's enough time, we can also use a little bit of the session in the afternoon. We might have the chance to even model it in Vensim. So then you can run scenarios on it and test it out, but we will see. But this time, I will provide you with the data. So the data should be not the problem. So the calibration of the model and the data is available. It's just, you should be able to conceptualize and identify units and the relations, and then the rest we can figure out when it is time. So yeah, start like best would be when you find one person in the group that already has experience in system dynamics. It could be beneficial, but yeah, start to organize in groups and please have fun and start the exercise. And if you have questions, you can always come and ask. Yeah, because you organize the group. Okay. You guys want to do And you two, you want to do it alone? No, sorry. Okay, I should mention this, like, you should model it as a CLD, course loop diagram. So when you don't remember what that is, that was the graphs that Luis was showing earlier. So when we have so the only thing that I want to see is the names of the variables and the relation of the variables. So when the births are increasing, the population is increasing, and when you have a negative relation, so when deaths are increasing, then the population is decreasing. So that's how you should make up this model. It's just conceptual, no numbers and nothing.
So what sales are? Okay, so I completely again, we have my investors. So we can revenues are and what the investment It's a variable. So the demand can be increased in new research.
Yeah.
And the more jobs that
Yeah, the productivity can be analysis of characteristics of each curve.
no,
So it can be the sum of the no, exactly, but then you can have met like more or less growth. So the productivity of the system increases.
Production increases, productivity is a function of amount of oil which is decided.
Yes, I think we're saying the same thing. The relative productivity is the same, but the productivity of the mind increases more.
And first of all, is how many stars are there. And first line is the and another line is the capacity.
For me, dwarfs are
Productivity is like a
the mining capacity of one dwarf is one dwarf per dwarf per year. So it's not productivity capacity. Unless you want to
So it's a variable that's unless you invest in the rest.
I haven't read anything. Like it says part one bridge like part one.
If you have the so proceed is so negative, and you have the good environment they reduce production.
Production also depends on the invest.
If you have
For example, like 6 force, and I would expect 3 years. But my productivity each year is followed by some percentage
as the same
because or less fun.
So we mine more sponge over the increasing fixes.
Yeah, the one more that's correct.
So this is doesn't really affect how many
Maybe we can build
we can build up some of these
everyone can build a smaller, lower.
I think everyone can build up some.
I'm trying to hear.
We have this, the most basic symbol. So you can do it with something. We know investment is amount of the works that we have in a year. I'm wrong.
Because identify the level starting what they need to do.
Starting the top 5.
Is there another very good
It is
mining capacity, production, higher production, mining production.
So then like the previous board, it doesn't affect the
It doesn't affect the market, but the productivity, right?
So you have the productivity of the mine is decreasing, so gold finance amount is decreasing by productivity. What do you do? Like you cannot increase the productivity of the block. So the only variable that we can increase is the amount of blocks. You can just get more blocks, you have more labor. Then you increase, like you make up for the productivity loss to the productivity loss of the mine itself.
in my head it doesn't
No, we have to think about two variables here. Think about it. We have like this variable, also you have the mining which is like more draw. I should have called it. I think that is the problem. So next we have the productivity per draw. So that is higher, and you have also higher mining productivity. I don't know, like here, maybe so then the mining, the productivity at the mine side more. Now we know more productivity means more. So we go around it. Means more gold mine.
Yeah, maybe it's why it's
so and then this one reduces. So this one is the function of so this looks like this. Productivity, think about something like normally it's a dimension, right? It's a dimension so now, like if it is here, it's one, but then it goes down. So if this high, this high, variable, the only variable that we are allowed to increase
Next year we will have some another word. And probably we will have
For now, like for
we have
only for
but it's
variable is not
my board and probably get along from that. The rest parts of the story, they invest in new. This is how and then here's my take. Just send some there is something I want to be
so that's like what happens
One floor can extract some amount of coins for you. So this is constant. And this is something because I understand the logic.
Take something that is not there. So each year there is less volume. So for them is the flexibility of the they can put on the market. They put it on the market. And that you need to invest in one you can mine one, but your mine is 0.9. So instead of the amount of the thing, you can use one and put on the market then it's more what we are doing is
I understand that the historical demand is driven by I think that's the
information about the market. We know the production is, we know, like, I think that's all. Some things are still being more number of processes also. Number of processes are higher with your increasing investment, but the investment is decreasing the capital. No, it was we have like investment and more number of like more investment needed means more draws higher means or more draws. It's difficult because everybody uses different terms for the words, but so if the gap between supply and demand is higher, right, then we need a higher number of draws. And this higher number of draws translates into something like the investment need or something like this. With higher investment need, we increase the number of investments taken. The number of investments taken decrease the commodity.
Exactly.
Yeah.
So this. Like these are
no, investment increases the capital stock, more capital available means more investment. It can be double. Like so, you have like one in this and one in this. Like that.
We need to invest
So guys, I think, okay, let's raise your point now. There. We need, like we can continue with this exercise, we will do part 2 and part 3. Now I think it's good when we present one time part 1, so everybody is on the same page, and then we continue from there with part 2. So I saw a look around, and I think you guys should present your part 1 and maybe on the whiteboard.
You can leave the screen up if you want.
How?
You have like it for like
Yeah, okay. So our diagram for Snow White fairy tale land, we identified three stocks, which would be the capital stock of Snow White. Then we have the second stock, which would be the number of dwarfs working in the mine, and the mine itself. In the second step, we looked at the inflows and outflows of those stocks, and we identified 4 major flows, which would be on one side the income of Snow White and the outcome based on the outcome of the investment. Then the second, then for the dwarfs, we have the hires of dwarfs, and for the mine, we have the production of gold coins, so the number of coins as outflow of the stock. And now we started to think about the whole economic system and how to connect this. And we started by, how did we start? By thinking about how to calculate those flows. Maybe we start with the production of the coins. So we had the number of dwarfs, find the outflows, then we have a dwarf production capacity as the second factor. And then we also had some production capacity of the mine, which was dependent on the remaining gold coins in the mine. So we have this vector and the remaining capacity. This would be some coefficient, we don't know yet, but it's most likely to be somehow decreasing with the remaining capacity within the mine. In the next step, we calculated the income of Snow White, which would be the product from the numbers of coins that are found in the mine and the exchange rate in fairy tale dollars per gold coin. Okay, and then we looked at how is the investment calculated. So the investment is calculated as dwarfs and cost per dwarfs, which would be some kind of wage and number of dwarfs and then the cost per dwarf. So we have this, and then the last, this is actually, this is like this. So the number.
Yeah, the investment allows the company to hire new dwarfs.
Dwarfs. Yeah, we had to find out how many dwarfs need to be hired in NASA. This was actually one of the trickiest parts, and we actually got some help in finding out. So at first we know there is a certain demand of $3 or 3 gold coins per year, and based on the output and this demand, we can calculate the supply-demand gap. And this, based on this supply-demand gap and calculated productivity of our dwarfs in the mine. So, yeah, maybe let's see. The number of coins divided by the number of dwarfs is the productivity per dwarf. And the number of dwarfs we need to hire is, or we would have needed this year to fulfill the demand, would be the supply gap and divided by the productivity of a single dwarf as it is. So we accept a little delay in fulfilling our demands, or we accept that we're always undersupplied, but we have somehow an idea how big our investment in new dwarfs is. Did I miss something?
Yeah, very good. Some things like what's important is that you put the like plus and minus on like how something influences like a certain variable. So what you need is, for example, here's also a link, like the more in the mine means more productivity means more gold point mined, and then you indicate that with a plus. If you have a negative relationship, do we have a negative relationship here somewhere? Oh, the gap, yeah, okay, yeah. More draws higher means, or more demand means more supply gap, or more gold coin mined means less demand and supply gap. So there you would have a minus relationship. So if you don't have like a system with 3 stocks, try to draw the system with 3 stocks and try to get as close as possible to this. There, because this is a good foundation for working with the second one, and you will need this to work out the second part of the model, like that the first part is working, and that you have the right connections, and from there on you can move on. So see if you have anything that is functioning differently that you missed, or you can ask if you want to help me finish with you the first part, and then we can continue with the second part of the exercise.
Yeah.
I will redraw this with the indications of plus and minuses. I think that's the easiest before I go around. I thought so.
Maybe better in another color.
Blue? Should I take blue again?
It is a little bit
Možete spremni ove, natječaj sam potpisala, kad ćemo ih ispunjavati to na idući tjedan. Pa da,
They consider.
it's the second part.
What they do now?
going now and get the starting point. We are on the same page. Then we will think about how we change the market influence our income. Because what we have is we have some kind of service. We have because our unit is one. That's my idea. We should firstly you just money amount is money amount and the production lower impact on the amount we are they have budget amount allocated by the price more the demand and less stock market. Maybe the idea is that here you have your selection right. Maybe by year maybe the supply is not each year the supply is not the same. This is also the main market. Yes, right. Market stock.
Yeah, I was talking
New extraction, so the production we have like
for everybody, like, excuse me, for everybody who is unsure, like the complete solution for part 1 is now on the board. If you want to check if you're right, if your assumptions are correct, and then you can try to integrate part 2. Or like part 3 if you're already there, but now it's like with all the arrows and with the plus and minus signs and everything and all the relations and everything.
I don't know. It's the same, but I can read it.
Yeah, but I was trying to draw the like. I think that this is a relation
If the boundary market is high, and it's minus 9, then you have an extraction of 0. So if this is high, the productivity is high, and then you instructions. Like just like to illustrate the concept of cooperation. Something like this. Sorry for my beautiful handwriting.
La línea de Lord's line. Like you're missing the arrow. No, the stop, the dwarf stop. That's you're missing the arrow, aren't you? Like it means you have this. Like here should be like here, yeah.
Yeah, here the arrow is here. Work proximity. From here.
Okay, but that's not the going out of the. What is this then? What is this?
This
stop? Yeah.
That's the drop step. It's just to indicate that it is a flow.
That's the big part of the Snow White. Yeah, you are. Yeah, he has heroes in the and the right there. It's like the first version. Now it's like the actual. Now it's delayed, you know. So we have the line just coming on the border line 0.9, and then we have the demand. Demand. Could be that the market could not supply the demand. So the gap must be something else. So we say from here we would take the flow to society is now finding the gap between supply and demand because it would be that we have like a high demand. We are correct. There's a big amazing. The supply to the society, the demand you take basically what is like the demand in the market. Yeah, yeah, they are. Don't mind the gap. Just listen that you have the market. If the market is low, then the price is high, and when the price is high, the income is high, and so on and so on. But don't worry about this month. Just see that you have like this structure of like, okay, I have something going to the market, something is taken on the market, and the relation to the price. Yeah. Because we don't have all right. They are connected, but not exactly. This is how we so market price. And at the one price, prices you're using these prices. So they can duplicate the variable. It's the same variable.
There are two kinds of
Subtle variables. Instead of simply saying,
we have two kinds of recyclable stage. First is to use the side the rest will be
separated as best visual like this society demand section, and then this is so the recycling because
That's what we work on now. It's clear. Some of these they will always die.
You could submit
But this is it's not my the number of points. That is not the actual point that
You have to work. What's called the use on that record. Some of them are not, some of them so this is to find the right way here says, according to the explanation, we have to translate the steps, so you will get a text
the price will affect the
Yeah, yeah. We recycle. Okay, so But I think that we should have here
Now you want to use vehicles, so you need like proper units per visitor, but they're available for
After some time,
and then it's
not sure that's
because we talk about different things, you get figure down in material for like consumption models in this and then over time
I don't know. I was thinking that the great get
how much these kind of things. So this is pretty much the when you open it now, you will see like this, and this one was going to
Okay, so you have like
the only actual thing which really influence our design.
So I think it's also lost on
It's consistent.
because now flowing from the market and recycling.
But it is the same.
Because the higher clients, and the higher demand, and you have two lots here, two lots yes.
Or determine prices of rates.
What's on the
You're right, that it does apply to loss rates.
When we have
We think that the loss that you have in the recycling process can be part of the recycling rate. I mean, affect the, we are modeling, so we should simplify the problem. We can use a core recycling rate, and the loss is part of the price going down.
So let's say we have the constant demand for a long time, so the price looks stabilized as long as we're thinking in the same model. Maybe quality.
It depends on what you need. What you think is better for that model.
The model is similar to feedback. We can do that. So we check the time.
The mass
more information.
And then we go back to the real time. So then, you are left with
rates, we can think about
yeah.
We have to outgrow. To this loss. Loss rate. Okay. This recycling that we have by the recycling rate. And we are assuming that this recycling rate we have integrated or we take into account the losses that we have yes. Just recycling, but assuming that given that we have a recycling rates. And we are considering that this recycling rate are closest to the recycling rate.
This is the market, then you go on the task.
Okay.
Yeah, so maybe we can do that. Maybe it's clear that the recycling rate is a fixed price. Maybe we can bring an auxiliary variable called whatever.
When we have like the three orders in the market, always in the market, and the price is always three more thresholds and the price
Here, and the recycling process, and we don't make the recycling rate.
Lower demand. Yeah, then it is the box is more full and the price is more available.
You must exercise.
Yes.
Yeah, catch up.
So, AI generated pictures. It's made with
Yeah, I was checking,
it's a draws for line and then makes it with the software.
Oh, you said story as a picture.
Yeah.
500 pictures.
Oh, this is more that is a bit of intelligence.
Yeah, it's artificial intelligence. The pictures are created by artificial intelligence by just putting in certain names or things you want to do, and then yeah, I guess. Okay, guys, it is time for lunch. We can continue after lunch. Next, you should eat. Maybe exchange between other groups and see what is going on.
What happened with this?
Maybe I take the idea for my students.
Yeah, do it. I mean, it's always good to have new tasks.
Usually, the most similar task that we prepare for them is about the fishing of code in iPad, by the way.
Ah, yeah, the fishing model, like strategy of the.
Yes, well, it's a version of myself, but the same idea of the fishing problem. And well, I think then some data, more it's realistic data about the fisheries, about the number of ships and the current capacity and so on. And they have
That's awesome.
yeah, it's a very interesting exercise.
Is it in Spanish or is it in?
I have a version, the complete version is in Spanish, but I have a version in English. I can send it to you. Okay. The English version. Sorry? Yeah. I have modified for myself just for my students, but it's more or less the same. Very interesting.
Actually, great instruction. Yeah. Interest rates are pretty
We have changed the parameters in our, so the fixed concept is the same as the original one, but it's that. Es que si me cuentas cada vez.
Voy al baño un momento.
mislim. Kad sam pogledao to, koji će da se nizne žute, što bi rekli. Zeleno su se, ali to je tretman da je to što vredi. Tako da sad on misli da taj gubitak snage i ne zato što nizne ne rade tako. Znači ne mogu izgavljati boriti kako treba. I što je normalno, da onda pada snaga i da sasvim odlično. Sad njene čisti prednješne i misli da je čisti da će to pokući. Ali dugoročno to naravno neće riješiti. Ti si sklona iskustvu. I kad staviš na dijagnostiku, on javi kad problem ne znam, tako da je meni to sve. On je opisao isto analizu pozitivnosti, tako da to. Da, ali taj lampica bi dobro korespondirala kao i ona za motor sa ovim problemom. Ono što se posmica prije svega. A to auto propizalo to ne može zato što tog čudnog, ajmo reći, sa snagom motora može misliti da nije na dobro popisno. Pa da, mislim, naša čulica, on će to sad sačistiti, on će vjerojatno pretopiti drugu okolo da ljudi će sturati. Pa, nadam se, to je ono što bih htio čuti, da. 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 Vidjet ću. Ali htio bih da ne sjetit ću se od znači, htio bih samo se dopeljati do cvjetne nutre, ali sad se da. 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 Ja. Pa sve nam je ostalo. A ne znam, on to napunio, ali ovo dalje, sad to čini da su izni, iako, velim, to sjeća se te diagnostike i to mi ne. To je jako onak teško procijeniti. Da. Ali ako stvarno, ali se problem pravi, onda ćemo možda zaključiti do toga zbog terapije koja djeluje, je to stvarno to. Da. Pa da.
It was very different. You said it's a tough time like this.
Pa mislim, teren je dosta neravno.
Kad idem u auto, to je kod robot. Kako, jedan drugi trok kada je došao do toga. Kada je došao do tamo, pa nakon ako ide recimo doma dok ne napravim to. Sad se nadam da će mi se dati ruku pa da budem ja desničan.
Antone, vodo jasno. Samo da te pozdravim.
Ideš?
I da ti poželim sreće do kraja neke škole, da sve bude pod kontrolom. Da studenti budu zadovoljni, studenti.
Što više utvrđivanja prethodnog napraviti mišljenje, to su ne sretni.
Šta si
Znači, kad dođeš s nekim mišljenjem, ti ga neko tuđe, onda si sretni.
A to, ja ti rekao,
Dođeš s nekim mišljenjem, pa ti ga neko govori, onda si naručiš.
pa onda možeš nevjerno skloniti što dalje, od ovih malih digrotera.
Pa dobro, zašto? To nije nikako sreća naša voda. Obrazovanje naše
Da.
sreća i znanje nisu uvijek.
Sreće su u istom živi.
Tako upravo do proporcionalno. Znači ono, misli si bolje da nisi saznat.
Da.
Ajde, sretan put.
Ništa, pisaću i idemo se malo. Da, moramo naći. Ovo je tako. Kad se ili već. Ne već, nima da dođe.
Yeah, man.
Yeah. Yeah. Oh, nice to have something in the stomach.
Will we here? No, you go.
Yeah. Then. Oh, God, just the time, right? Half an hour or something, 20 minutes? Yeah, half an hour. And then the last round. Yay, 2 more hours. But I think, what do you think? You like the exercise?
What's so difficult? Maybe you would prefer events.
Yeah?
Instead of
You want to do it in men's? I mean, we can do it in men's, and that was the plan for the last half of the exercise.
slightly more interesting because then people can run and see
What the effects
it's going upwards actually.
But the thing is, you have to conceptualize first, because I think most of the people are not used to this kind of conceptualization, and when I let them invent them, then they just build everything, but it has no meaning, like because the connections are wrong. But it's a good idea. Like I have, I mean, this is part 5 to do this. Maybe I give maybe 15 more minutes to solve the task, and then I will reveal, and then let the people build it.
Yeah. Because then there is some feedback when they see it.
Yeah.
Yeah, some better.
I will need to work with this computer in the second half. Is that possible? Yeah, but I need. Yeah, oh, that's nice. Thank you. No, it's possible.
You didn't try.
Oh.
Yeah.
Of course, we don't have draws. We have like mining efficiency and technological improvement and stuff like this, but something similar. And that structure, especially from the market and from going from market to supply and society, from supply and society to recycling, is also similar. And I will use copper and oil as an example for the materials.
As you mentioned this morning, you also talked about the copper needs in different sectors, like the 65 sectors.
Yeah, but that is done by this one done by the economic ones.
Okay, yeah.
So when you imagine the input-output table, like we have this 63 different sectors and then 35 regions, right?
Yeah.
So let's say we have like one sector, which is like, first of all, we change the sectors a lot. But here's like the sector mining copper. And then in the data set, there was usually like a set which is called base metal sector. And that sector has refining, it has secondary, but from many materials, like not only from one, because they merged in this. What we did is we break secondary copper out, put it in this sector. What we did as well is like refining copper, we put it in this sector. So we have just one sector which is associated with copper, and this is all the activity in the copper industry. And that is in monetary terms. And then we translate this monetary terms by calibrating the model into, like, with an implicit price. It's not the real price, but it's just like a tool to translate it into the million tons that we have for the base year. So base year would be 2015. So we divide it by the implicit price, and then we get like the right amount of million tons that should be extracted according to the productivity of that sector. But then you have to imagine for each of that regions, they have like a coefficient or a share of these monetary values, and also for each of these sectors they have it. Here it's pretty clear, because then the mining copper sector is like, maybe you need 5 copper for the car industry sector in region A or something like this. So that's how it is done in these regions. Because the problem would have been when we model bottom up, and then have on the other hand the data set with the sectors, these numbers would never match, because depending on which data source you use, one or another would be compromised and you would have to leave it out anyway. So that's how we solve that issue. But that is tomorrow you can ask everything about the input-output. I know you're really interested in the economic model, so you can, tomorrow is your chance with Inaki. He will be able to explain this. But I can show, and that is the plan for today. So when we do the exercise to the end, and then we have maybe a Vensim model, and then I will open the Vensim model that we have in William and show William. And then I can show you directly, okay, where does the material model end and where does the economic model begin, and then how does it communicate with the materials mathematically and also like logic wise. And the same, we have like the same interactions. We have like the economy model, and then we have the energy model, and then the energy model is giving information to the materials model, but the materials model is then reporting information back to the economics model. So it's going through all of them. So, but that will be more clear when they, when they explain their structure. But I will try to capture at least what it does in the fundamental sense and where we have these connections.
Did you receive an email from Luca?
Yeah, thank you.
Let's try to secure this meeting.
Yeah.
Let's try to
qualcosina nasce, tanto questa stilisce, queste passano ok. To sam neki dio, tak.
I would recommend muting yourself and I.
Ja.
Not yet.
Okay, it will take soon up to 5 minutes to recover.
Okay, I will have that in mind. William is driving me crazy. It takes forever to calculate. I just wanted to have some test runs to show like what kind of implications they do, but man, in your terms the household of four, and then like there's a loss rate, so like let's say 5% is the loss what we lose per year. And then we have the going from board coin and use sent to recycling, determined by the use time or by the amplifier of the scrapping. So Arbeiter hire more of the stuff that's in the household. Recycling, the price lower, the amount is lower. So and then it ends up in the recycling stock where we have the same loss. So we have like the recycling percentage tries to regain as much as possible from the resources, but we have 5% loss rate. And so these stock here, this one is like getting recycled and entering the total supply, or in this case, the supply to the market. You can leave this variable out of this calculation. And then we have the recycling amplifier, which is also a relation of the price to the amount like of the recycling rate. So the higher the price, the more likely it is.
Because I probably want to remember when I'm taking a picture, so we bring it out.
Yeah, you can take a picture. I mean, I can zoom out a little bit, that you have the and then just take a picture. Forget about this, because this is just for, like this variable is, I just put it there because I needed something to initialize the form. It's more about this.
Okay, everybody, you get like around 7 minutes to wrap it up. 8 minutes to wrap it up. And then we will reveal the solution for part 2 and part 3. And part 4, I can draw like an idea of the solution, but it's not what we will actually integrate into the Venson model, but it is important because it's a part that we have in the William model usually. But I left it out of the Venson modeling exercise. But try to finish as much as you can, and then if there's volunteers to present part 2 or part 3 at the boards, you're welcome to do it. So.
We should deliver something. No, but I'm talking about meetings after now, or even that we have. So, that we have some ideas.
What I'm trying to say is like the more you're finding computing pressure, the higher the increase to the drain storage. The more you find, because they can't assume these blocks are next to each other, and then you dig the mine into the next box, so your mine is still the same mine. So you're expanding the mine, then you find more, so you take more of that's maybe we can move it to the gold mountain, so that's then known quantities that you can find, and the other hidden treasure. So that I was probably too tired.
Okay.
I fucked up this. I just read it, like it's very stupidly written. Yeah, I fucked it up. Like I'm not very because it's something that I have to get it very late.
How did you prepare this exercise? In which, how many hours?
Today, maybe drawing the CD, but the longest part was the conceptualization. Because I have evaluated model as like data. So that was worse than the conceptual.
Okay, so here we have one condition that stock is and the productivity decline. So we have one regulation, of course. So we need to have positive shock. And we need to have some border of productivity. So it's from 1 to 50%.
And the productivity.
And then searching levels, searching the effort results. So there's investment. This kicks off investment in search. Search efforts, we find higher.
But I have a question. We have like investment here. That is another
one investment should be like right now the job.
So we need to create or merge the
I don't think you can because remain
it's all really goes down.
Investment in workers, investment in it's very well defined borders.
And this is the productivity of the person.
And then this investment can be higher or lower. It's higher than
Okay. You're thinking about the spiral yeah.
More time, the decrease of the number of So hidden treasure is a new way, right?
I think we can it's not here, so we can adding some properties that we can okay, so we move on to the you increase the searching for increase. So you have more
Jeśli mislimo da bez veze ne snijamo, ali ako oni šimaju nešto bude opet.
Zato je prebacujući na njegu.
And this is exactly so that is your separate for music.
Yeah, because one
you're part of the board for
and
this
additional investment very well defined border values.
Okay, let's say we want to just reach the final outcome.
So now we can break it. Nice. Okay. Take a look at some more ideas.
Can I borrow your machine? I don't know where mine is.
When it means they're in high demand these days.
There is a mistake here, but I cannot say that. There is a mistake. I mean, I can understand.
Part 4 is written in Turkish.
I can understand the view of all the yeah, I can. No, I can't. You are the two. The potential candidates to run. We can, let's say, we can 1 year. I'm not right, that's what I try to say.
Okay, I decided to show you part 2 now, instead of, because we're running out of time and I still want to show you William. To resolve part 2, we don't need much. Like it is just like that we try to capture the market dynamics. They are pretty similar to the ones that we use also in the William model. So what we take is the gold coin that is mined and we supply it to the market, because there's interest, like the inhabitants of the fairy tale land, they want to have some gold coin for their home, maybe make jewelry out of it or decorate their houses with it or whatever they do with it, pay fairies for doing spells or whatever. So that goes into supply to the market. So the more gold coin we mine, the more supply we have into the market. Then we have the gold market, and if the gold market is full, so there's an abundance of gold at this market traded, then the price is lower. If it is the other way around, if the gold market is very empty and there's a tension, then the price will get higher. With a higher price, we have also a higher income. So then we have also the demand. The demand is we're requesting from, or like is determining how much gold is supplied to the society. So the higher the demand, the higher we can supply or will be supplied to the society. With one exception, we have the limitation of the available of the market here. We deplete what we take from the market, and if the demand should be higher than what is supplied to the market, then the price will be high, and only like by mathematics that you do with a mathematical function, that it is not allowed to take more than, like, so when the stock is empty, it cannot take whatever. Like, so it takes only what is available. So that would be part 2. I would recommend you to take a photo if you want to integrate it into Benzem later, if you don't have the same engine yet. Maybe you have the same engine, I don't know.
Yeah. Why income is not that low for capital stock?
No, I because income is the inflow for the capital stock. I just showed the part 2 because I have limitations due to the size of the board and my shitty handwriting and the distance you're sitting in. So I'm trying to, so like, this is of course influencing the income which is going into the capital stock. It's just this snippet, like this little part 2 that you should consider. And now I will start drawing part 3. And if you don't have it, update it maybe in your drawings, and then we can use it for the random exercise. Okay, now we have part 3. Like so, the part 3 of the exercise was to model the household and the recycling of materials a little bit in a simplified way. So we have the materials that are moving from the supply to society into the households, where we have like a certain amount of gold coin that is lost on a yearly basis. So we have a loss rate. And so the more materials we have in the household, the higher the amounts of loss there will be, because more people will lose their phone, more people will lose their keys, more people will lose their car or whatever, or their gold coin in this case. And then we have like this constant outflow out of the society, like materials that's lost somewhere and cannot be found. So then we have another outflow about sent to recycling or sent to scrapping, which is defined by the use time, like how long do you use a certain device, or how long is a certain thing in use. And also the scrapping amplifier, which is the function of higher price, more likely to be recycled, more likely to be cycled, or more like higher recycling rate, more sent from the households to the recycling store. Then we come into the recycling. So when you take the material in consideration, you want to recycle it, you have always a loss due to the thermodynamic law. So there's always like a little bit of a loss. You cannot get 100% iron out of like the iron that you put in. It's maybe 95% because some of it is disappearing during the process. So you have also again a loss rate that you define in a similar way here. So higher the loss rate, the more the loss. More in the recycling, you lose more, and with more loss, you have less in the recycling, of course. And then there is the gold coin that is in recycling. So we have a certain amount that is in recycling, and the higher the price, the more of it gets recycled, because it is profitable to do it. We didn't consider here the price structure of recycling or anything like this, but we just say like, okay, when we have a high price, more people will recycle. You see that actually happening with gold, because gold is like one of the best recycled materials in the world due to its high gram price. Like, because nobody wants to lose it. Like when you have teeth from your grandma or rings or something, and you don't want to give it somebody in the family, then you will bring it at one point to the gold scrap because it brings you a lot of money. So then with the higher amounts of recycled material, we have new material available that we can feed into the supply to the market, which is easing the situation in the gold market, because we have a second form of supply in that sense. Like we have like one time the gold coin mined, and then the recycled gold. Part 4, I wrote a little bit, maybe too tired when I wrote it, but the wording was not correct. I will show you part 4, I think after the exercise, because I think it would be interesting for you guys to try to model it in Vensim. If you want to take a photo of this, please do, because it could help you modeling it. And then I will put on the projector again and show you the data and the initial values that you need to put into the different kinds of stocks and flows and and the mathematics behind. So you should open Vensim, maybe 1 in the group or 2 in the group, and try to model it. Or like if you want, try each on your own computer. I will try to give you 45 minutes for that, because then in the end I really would need and want to show you the William model as well before we finish.
Can I ask a quick question?
Yeah.
Why there is another error for the supply to back to those?
Because everything that leads to the society is located in the stock. It's just when you draw it in system that
Okay, so I would, for example,
flow is already this negative arrow.
to the stocks, like the characteristics of the stocks somehow?
Which ones? Yeah. These ones or?
Not really.
Or this ones?
Like for example, use time is something that is decided by culture somehow. So it is affected by other stuff, but it kind of, in my head, it belongs to households, you know? I don't know if you have any way to consider like.
Yeah, you could, that's a very good question. You could use something else in the stock, it's called conveyor, for example.
Okay.
So then, like everything that enters the stock is like sitting in the stock, and then after 5 years it's popping out.
Yeah.
But since we just model the stocks, we just use the
Okay. Thank you.
No problem.
Why the recycling linked to grow in refining?
Which one do you mean?
This one.
This one?
Why is it happening?
Thank you. So, if you want to look for equations or values, you can come to the front and like scroll in this Excel table. And also there's the model open on the other side if you want to check if your progress is according to what you think it should be or what it should be. But try as much as you can now by yourself, just for the initialization, so like putting the initial values or something like this, try to solve as much as you can by yourself. And really, what is very, very important is that when you put this together now on Benzene, that you define the units. This is stellar, it is pretty much the same as Benzene.
But very important is that you write really clearly here, this written down here, and in Vensim it's in the equation bureau, that you write what kinds of units you have. Otherwise you will get unit errors, and that means that your model is not consistent in itself. And we try to build a mass balanced consistent model, and now you get the experience between different units, because we talk about gold coin, and we talk about dollars, and we talk about dwarfs, so they should be consistent. You cannot have like a fairy tale dollars is not the equal amount to dwarfs. So like there's some things, some variables that you didn't have before. Think about the salary per dwarf, for example, and then since the dwarfs are the stock, we didn't model them with an outflow. So we have to have an outflow, because otherwise we just have a lot of dwarfs, but they need salary per year, and they don't need salary, one-time salary, and then they will work forever. Then we would have bought them as slaves, which is not the reality. So they have a one-time contract, and that's their outflow, as you can see in the top here. So they are hired on a yearly basis, and then they are kicked out, and then Snow White Capital Inc. Decides if they can hire more dwarfs or not more dwarfs in the next year, based on their capital stock. So that is some things to consider. If you want to check if you're going in the right direction, come up in the front, and we can go through it and enjoy.
We maybe we can choose maybe you would have we can just say that part run, but then use it one to 2 years, we have a time series for a year, but what you can say is, okay, they got we're taking same as the energy of one. As you say, and you're talking about energy model. Okay, which are the inputs and the outputs of the it's not it's calibrated to be but then you have this, then you have like they will interact with the demand it's like a loop. All you have and you have like the sector is going to have the different cells with the so you have like two phases you have the energy work in energy market or also interacting with the material because you have to extract oil or whatever resources that you need and it's like a loop between the elements of the ore and materials. If you have scarcity in some resources, it will affect demand. So we will have an increase in the price, and then we will have an increase in the demand. And start taking hold of the summer behavior. For instance, when we're rich, we are seeing the price go up. And the same for example, for if you have a carbon price. So the carbon price and it will affect the final price of the electricity. And then you will have an effect on the demand. But it will affect, as you mentioned, the benefit for your price of the different.
So what we have is we have the gold mine coin that goes here, and that's the mining income, and then we have the gold price like that is here. Here we have the supply to the market and the gold coin in use and the gold coin in recycling, and then here we have the gold coin recycled that goes here to the total gold coin supply, and here as well, and that enters the gold coin market, and this is just like this plus this.
So then it's alright, but then I don't have a cloud here now, so
yeah, sometimes when it's just a little bit late. That's why I did it, and that's because it's much
Why do you use standard set of
because it's really nice, in my opinion. Like look, for example, when I want to see a graph, I can just here and I have the table directly. I can see the results. I can like it's not that clumsy as you can see. You can just click variables, do something very easy. It's not. You cannot fuck it up so much. So like when you're here and then you're like, oh, I don't want this variable. It's like okay, and click it and just check.
From the point of user interface, for teaching, It's definitely better because you can project like faster. And there's also another one, but I mean, this is like, of course, if you're used to what you stick to, but I trained on this one, so it can be much easier.
You can model the code as well, rather than there's still a while other things are working.
No, we modeled the materials in this one, and then we had to transfer it automatically, which was a chaos, which was not automatically. You actually basically do everything in the beginning. So because we have like a big world model, something similar to LOCOMOTIO, with a lot of materials. With way more than we have in LOCOMOTIO, for example, but we needed to extract that and then of course modify that to the need of LOCOMOTIO, and that took a lot of time. But they're pretty similar from the
Can I help you?
Which part do you mean?
No, but if you're expecting,
Drafts working. I have, this one is just like for initializing the model. After work done. This one.
One year less
See, no, I just have like the contract time is running out. One year contract to the conversion, 1 year, it's calculated again how many drops we need.
Yes, I want to we can find
how many errors do you have at the end of the
but not find them.
Yeah, that's true. Then we will have the same conceptual error that is something that you absolutely need.
Okay. So I think we could now start with equations. It's like we have some things that you have, we don't have. Like for instance, mining costs, having the investment rate here.
Okay, this is uses variable, so you can get rid of it.
Mining income, profits.
Could be just going in here. You can calculate it in here. So when we want to, where do you want to start, for example, to get it running? Should we start with initializing the? So we can start with the initializing the stocks.
So
what kind of unit is it? You start.
Okay.
So in this kind of
And it's like this is what is it? Productivity, which is coins per hour, times the productivity which is
that should be
gold coin in the mountain is gold coin in the mountain plus minus minus the outflow actually. So you just have gold coin in the mountain. And you don't define the equation in the take it out, and then it's just initial, put an initial value. Is it reserves mine A? Yeah, 200. Then reserves mine A minus your what is your flow cost?
It's dwarfs employed times labor productivity.
Yeah. Okay.
Can you
so here this is our it doesn't have a name.
Okay, you have to give me this.
Okay. It's not just taking the charges and connect it with It's part of the work, so it won't be great. But what you have to know is that
Also doesn't have a cloud.
It's weird. So it should be like gold coin mined, for example.
Okay, and I will create a new Okay. Okay, actually, we need the number of dwarfs employed in mine A and in mine B.
We don't have the mine A.
Okay, fair enough.
Okay, and here I did something. That is something to trick the model. That's good that you're here. So because long time we can, like when we run it, there's a long time where we have where there's no need to hire dwarves, right? So we make an assumption. In the beginning, our dwarf workforce is 3, and they're really obedient to Snow White, and they work for free. Right? They work the whole time. So because that is just because I didn't have time to do more initialization. So we have like the draw, like, so I call it workforce productivity, and then we have like a dwarf mining capacity and the dwarf workforce, and then we have the equation. So the dwarf mining capacity times dwarf workforce is the initial one, plus dwarf mining capacity plus dwarfs working. That's the one that we will hire in the future. Okay.
So I just add the workforce. Dwarf slaves, I call them.
Yeah, that's good. You're free to do whatever you do. It's like your mind. It's a mental model.
And like this was what you put just in the initial value.
No, the initial value equation is this is 200, yeah, and then this minus the flow. So when you have this, like here it doesn't show it because it automatically does it for you, but when you look at the equation, this is gold coin in the mountain, gold coin in the mountain, yeah, plus minus the flow.
Okay, but I can also conclude, so this is the dwarf slaves. There's the
We have just a link
These are the initial 3 dwarf slaves.
Yeah. And then
the initial dwarf slaves.
No, that's the dwarfs employed times the labor productivity.
And where does the productivity of the mine, which is like how much
this is just like a lookup function basically. So what I did is like I defined this lookup. Like I said, like okay, when we have 200 gold coins in the mine, then up to 150 we can produce 100%, and then it slowly starts to decrease. The productivity slowly starts to decrease. You can just do a lookup between 101 and 1 and 0, and then you put it in here, and there's like a dimensionless variable, and you use it as a multiplier. So in the beginning, it's one time what the workforce could do, but then the quality of the gold coin is less than that. So maybe one gold coin is only 30% of gold is marked, so they need more workforce to get the same amount. So it's like a little bit to emphasize this
Now you have this separated in workforce productivity per year and local mining. I don't have workforce productivity per year, so I have to insert all of it here. and the multiply this term with lookup und dann
Yeah, with the percentage of qualifying, I guess.
Hier muss ich dann so
Lookup machst du, wenn du hier Auxiliary,
genau, ich weiß, wie ich eine Lookup erstelle, aber die Lookup erstelle ich erst woanders und hier nutze ich die Lookup, die Productivity mein A heißt.
Ja.
Wie mache ich das?
Okay, achso, ja, dann sag erstmal Productivity mein A in der, die du jetzt oder so schon hast, das ist eine Variable.
Genau.
Ja, okay, dann machst du Check Syntax. Und du hast
Achso, ich habe da fehlt noch die Connection.
Ja, okay, aber ist okay, die haben, ich glaube, die hat er jetzt automatisch gemacht. Manchmal macht es automatisch. Und dann gehst du auf die Productivity,
Ich weiß, wie ich hier die Lookup mache. Dann muss man das jetzt bei mir wissen.
Ich gehe hier einmal eine Runde und dann komme ich wieder. Nein, wenn du es wissen willst, dann musst du ja fahren. I just looked if it makes sense, which kind of order of magnitude I'm using, and what's the relationship between each of the minor. So this is just an example. This one, this part I didn't know. It was more for data. So you can find out the keys in the video for the yeah, it's very good that you, like, I mean, that's what we do in the economic model and over we don't do it in this version, but also what we did with the so we have a very high price in the demand. But I think it's not like in this house, we can also, it's very good, but we will not need a price. But it's correct. Conceptually, it's very correct. If you have some more questions. Yes, yeah, so in this case, the gold mine minus the gold mine. When you want to fill in the data, so you come on the Gonzalo, one question. Can you put the source and then automatically negative?
You need to avoid the non-reference.
Yeah, but I don't want to also. Because in Stella you can decide that you cannot take out or
Keep the names.
brilliant. That makes the song
If you take this, you know, like I have here the option to say non-negative.
Yeah, I know. That is
So this cannot go negative. Can just go empty. Or like in this case, yeah, like here it can just be 0. Like for example, we have 0, and then it can be less. But okay, then, but I think like with this data we don't have, like it doesn't count. Like as long as we don't do extreme cases, then nothing happens.
No, it's not a problem because which is the variable stock.
Yeah,
you can say if the flow, if the stock is lower than 7, there is no option.
Yeah, you can also write maximum function. Make the maximum 0.
More questions?
How, so in the lookup table here, now what I want is the lookup table should transform the reserves into the outcomes. Like my input is how I think it's now. My output is, okay, hier wird dann dimensions. Ja, aber wie ist die Form? Schreibe ich hier.
Da packst du eigentlich die Variable rein und was mal in die Lookup ist definiert. Wo haben wir eine Lookup? Hier haben wir eine Lookup. Auxiliary lookup, with lookup as a graph, and then lookup is here, and the equation is like so the dependency is this. So like then also here type auxiliary, and then lookup, und dann nimmst du das raus, das da oben.
Cool, danke schön.
Kein Problem.
And the flow is points by negative.
Now everybody feels like we feel on a daily basis. We have to do this all the time.
We need a razor. they're going, the flow from output to recycling based on the price. So a particular is between 0 and 100. Okay, so
Yeah, it's 0 and 1. So like an S-curve shape.
that's true.
Yeah. So imagine an S-curve like from 0 to 1. So if the price is like, initialize I mean, you can see what I initialize the price. The price is like, the price is going higher than the usual price, and
But the price is messed up. Prices
it's a function.
It's a function that I need to go with the fund.
Yeah, you can go check on the question.
But the effect is the essay, not the price. The effect.
You mean the scrapping amplifier is like an S shape, but the price is not an S shape. No, das ist.
Was du mir gerade gezeigt hast.
Also ja. Warte, aber das ist eine gute Idee. Ich muss ihn. Ich muss das eben im Hintergrund laufen. Jetzt können wir zu dem anderen gehen. Was wolltest du gucken?
Wie du Dwarfs Needed, abhängig vom Preis und von Supply plus Demand, Demand plus, also das hier modelliert ist.
Okay, also ich habe hier Total Gold Coin Supply,
Ja.
Und die Demand.
Ja.
Und das ist die Funktion Total Gold Coin minus Demand times, also in Klammern und dann times minus 1. Okay. Weil sonst ist es eine negative Funktion, aber ich brauche positiv. Also ich will, dass der Wert positiv ist.
Aber das muss doch eigentlich auch noch mit der Labor Productivity zusammenhängen.
Das kommt im nächsten Schritt. Ja.
Okay.
Im nächsten Schritt habe ich dann Dwarfs Needed und Dwarfs Needed ist.
Also das hier wäre schon Dwarfs Needed.
Dwarfs Needed ist Gap between Supply and Demand. Also das ist wie ich Supply and, also Gap in between Supply and Demand habe ich so modelliert, damit es weil dann kriegst du positive Wellen. Am Anfang negativ, aber wir können ja keine negativen Dwarfs needen. Also wir haben kein negatives Investment. Und dann ist die Funktion Gap between Supply and Demand divided by dwarf capacity times productivity. Also eigentlich bei Working Force meine Sprache ist durch. Aber diese Beschreibung ist nicht so, macht die Zeit nicht. Ja, weil wir immer so schön, weil wir auch nicht anschließen. Weil der Wort ist nein. Ja, weil nur die Luft hat. It is also possible.
Proving. Are you comfortable with this one?
Richtige Spaghetti. Sehr bei dir. Vielleicht ein bisschen überambitioniert, das jetzt zu simulieren.
So lange. Das hier Goldkonto hier ist
Meine
das, was bei mir
Productivity.
mein Productivity ist.
Ja, Productivity.
Okay, anyway, so was needed bestimmt dann Firing. Und Firing. Ne, Firing ist bei dir nur abhängig vom Contract, ne?
Ja, Contract
Die laufen
Time
einfach
von
durch.
Die sind nach einem Jahr wieder raus, die Jungs.
Außer die Slaves.
Ja, die sind immer da. Die drei Kadetten müssen immer da.
Okay.
Die sind definitiv so verfallen.
Ja. So.
Die müssen nur mit vergifteten Äpfeln bezahlen.
Das one wäre das hier. Das sind einfach Coins.
Das sind Gold Coins per Drop per Jahr.
Und das sind
Einfach eine Gold Coin. Ja.
It's good. So you're not running out of gold coin?
Yes. For my daddy, for my daddy.
There's pretty much when we run out of gold coin. Yeah, but you have a lot of profit. But why do we have so much profit?
We want profit. We are trying to get fast.
We are paying the salary once a year. Same way.
You also made it smart instead of modeling the also.
I mean, I thought that like this is the night, you know, where it starts loading and go be with it.
Yeah, because otherwise it was right.
Yes.
Yeah, but okay. Why do you have so much profit? Do you need where's your hiring company? Oh, you're hiring like 100 hours. Okay, but okay, no problem. What's the salary per drop? What you have a salary of 1 per drop? What's the gold point dollar per Look, I used it half of it, and I run on farming up the state.
Yeah, yes, just the investment needed is not connected. Because it's not connected to the demand side. That's right. Otherwise, you would have like a higher investment because you need way more. And also, you also need to be hired again. You just have to one. Otherwise, you accumulate it. You cannot pay it. Because you pay the investment is taken for 1 year, so they work 1 year, and they leave the company again. You just make an outflow of the stock, and say like contract time 1 year, so then you divide the stock and divide the money for the drops we have in the year, and then you are and the model is really the amount of stocks needed to change the money. That's the reason, because when you invested one character, you bought a lot of jobs, but you work forever. So you bought a lot of people that work for free, and you pay them next year. As you can see, it's very profitable.
So now we
the reintroduction of slavery will solve many of our
this year. And you will try to run some
okay, so then when you have
the idea is to try to find away with those kind of we don't have knowledge about the residents also about the communities. So we take models maybe it doesn't exist for or USA It is more about topic for the quality of
divided by 1 year.
So, sure. I mean, that's an idea.
First question
you might have deliver other Orthodox. There is a six model, there is a model that they use, they don't have money. Just as the event, so they try to wash something model. Here what we have is more we can use more simple this is just what you have to is I know the data center, I know the data. It's just, I know the data is the whole one that is the developing strategies, I know the consumption. And one problem here is that basically the classification very usually
Let's make a little bit of William as well before we But we can, I mean, if you want to finish it, you can build it to the end.
Okay, excuse me everybody, I have to interrupt your beautiful modeling session. It is very nice that you're so into it and that you really try to figure it out. But the topic is also William about the summer school, so we should look a little bit at William. But now you have at least a good foundation how to understand how this resource modeling is working in a simplified way, and you will recognize some of the engines that we have also introduced into William that you started to model now. I can offer for the people that want to finish the model, I will stay and finish the model. But for the people that want to like have a working model at the end result, I can also offer to build the model in Benzim for those that might maybe enjoy the sun more, or beer, or whatever they want to do. Then I can send it around. But then you have an idea how this exercise should be finished. And it gives you a good experience in general about material modeling. And you will recognize now a lot of the engines that we have in the William. So I will show you some. I hope our modeling is stopping now because I just run some simulations. But I will use an example of the copper model, and then we can compare it to the model that you guys built. When we look here, oh God. Ah, okay, maybe there's hope.
That's also more or less.
Okay. Yeah. So if we look at the copper model, this is like one of the materials models that we have in the William model as one of the materials model, and it's also one of the most advanced ones because it's already connected to the economy model now. So what we see here is like, here we have the copper stock that you would have as like the gold coin in your mountain. This is the stock that you have modeled there. So this is, but this stock is not a singular stock. The stock is divided into 6 different categories. And the categories are divided into different ore grades. So we have like rich ore grade, high ore grade, medium, low, very low, ocean grade. So we have different qualities of copper and different reserve size of the quality of the grade. And here we have like resources that are identified where it is likely to find something. That is the part 4 of the exercise, which we didn't model, which we didn't integrate into the Vense model now. But that is like the copper reserves that are classified by a geologist. They are potential economically viable for mining and have potentially this and this kind of ore grade. And they are also separated into the 6 classes, and they have also different sizes of these kind of depots. So what we have here is then a function that describes how quick the prospecting is likely to happen, determined by different factors like technological improvement and also like the interest into doing this, like profitability and interest into getting into these material grades. And that moves then to the stock that is actually operating mining capacity in the moment. From here we have also the mining that takes place. As you can see, the mining is actually influenced by way more factors than we just modeled, but it is, in the end fact, it's just like different kind of influences that do the same in the simplified way as we did it now in the Vense model. Then we go over. So this is something that you will recognize as well, like this structure, because you just modeled basically a very similar structure. It's not catching up. Now we have it. So we send the material that we mined, so that's the CU extraction, that is the ball that just moved from the side here, like this arrow. This is the total amount that we extracted, that we collect from this arrow. That would be recycling, that would be secondary mining. Secondary mining is like when copper is not the first objective to mine. Maybe they mine like material, I don't know, iron or something else, but they are lucky and they have also some copper in these materials. So we sum that up, plus the mining from the different ore grades that we have, and then the mining from recycling, and that enters here to our market. And then from the market, you can see like it is traded to the market, and usually there should be somewhere an arrow, I cannot spot it now, but the market is also influencing our price function in this case. And then we move the stuff from the market to the society supply, as we did with the gold coin, which is here. And this is also, in some materials, it's also areas depending on different uses, different kind of uses in society, different kind of use times in society. So according, as you saw earlier, when you remember this pie chart in the presentation, we have like certain amount of the materials ending up in wires and construction that has maybe longer retention time or like holding time as like electronic devices. That is not the case for all materials. For some materials, it's like more like an averaged approach, but we have like done this kind of segregation in some cases. So, and then we have also here the loss in society. Some of the materials lost. It's just happens. I mean, everybody loses something. Some things are not taken care of properly, or they get disposed irresponsibly, and then they're inaccessible for recycling or retaining that material. And then we have here the flow from the stock and society going to the scrapping, or in this case, like the recycling. It is also influenced, what you cannot see, it's not on this chart, is also influenced by something like that is driving the price. So there's a base rate that is representing the current state of the art, but with like rising prices, it's likely that we pay more attention to the material in our society, keep better track of it, and move more of it to the recycling. So when we go here to the recycling stock, we have also a loss of material even in the recycling, because recycling is not perfect. We are quite advanced, especially in copper recycling, we have like really high return rates, but it is not the case for all materials, and so the loss rate in recycling varies depending on the technological advancement of the recycling, and and also on the amount available for recycling. And then we have like the recycling is also influenced by a price, and like we have also a base recycling rate, which resembles like the recycling rate that we have currently in the society. And then with higher prices, we have more like the potential to recycle fundamentally more. I want to switch in German now. So my brain is tired, that's why. Then we move the recycling also to the market and fill the market so there's more copper available again. I want to show you some extras that we didn't model or that we didn't talk about. There is of course more detail. As you can see, the model is much.
Just one quick question. Does the market has some kind of limitation in the sense how much can it receive?
How much it can receive, it has no limit. I mean, the limitation comes from the capacity, what is able to be mined. That will be explained in a bit. Like so, like we cannot increase when you have like an increase in demand by, I don't know, 50% from one year to the next year. The model will increase the price dramatically, and the markets will be cleared. But it will be not able to fulfill these kind of demands in that sense. So it takes time until the model is like ranking up the production capacity, and then the production capacity is sitting in and filling the market slowly later.
So the market, the model can't not predict, but can't describe any kind of market distortions in a sense like China decided not to import our plastics, pen, stop. In that sense.
In that sense, not, but this would be handled over the economic model. So because the demand is coming, like you can run, now you cannot see it, but could you zoom in on the market stuff? So the demand in our model is like a function, like in the original model from Harald's idea is like when it was in World 7, is a function of GDP prediction and copper per capita needs or desire in that sense. But now this demand function is not existing anymore. We have now a new demand function. That's actually good that you point that out, because then we can dive into the connections of these models. And then I can answer your questions with this. So we have here a switch, which is like, okay, we have either the historical demand or the demand that we can use from the original version of the model. Now, this is the historical demand just from, like, I don't know, from 2005 until 2022, because that's when the model runs. And that's also how the model is calibrated to price, cumulative extraction, recycling, and so on, like all these kind of factors, because we can track certain lines and see if the model is reproducing the behavior by just putting one input variable there and seeing if all the other things that the model does is doing what it should do. So now, when we have it in William, in the William context, it's a different world, because we now want to have the copper demand, and we want to have it according to our scenarios and our predictions in the economic model. That is coming, like, so the economic demand is coming in monetary terms, and we need to calibrate this monetary terms to the base here. So it needs to be like, let's say it is 10 million euros or dollars in that case. And we need to divide it by an implicit price. It's like not a realistic price. Maybe when we are really good and when every assumption in the model is very good, then the implicit price and the real price of the commodity are very close together. But you translate it into million tons per year. So that is the demand of that year. And this demand is then supplied to the market, and then in the other part down to the right. And down. Yeah. So is then supplied to the market, and then we calculate the price, and that is the signal that the economic model, or the language that the economic model is speaking again. So after this happened, and hopefully also close to the historic data for the years that we feed in the beginning, and then according to the projections, we have like a translation of the economic or like of the price we calculate in. So let's say it's close to the real price, $8,000 per ton or something like this. And we calculate this into economic terms because the economic model works with normalized prices, and it starts with a value of 100. And then we track the price change, how it affects the economy. Is the commodity getting more expensive, or is it getting cheaper? So now when this comes into the economic model, that is the part where I can answer your question. Because this is this price is delivered into the economic model, and as you know, the economic model is separated in 65 sectors and 35 regions. We model our model on the global scale because it is much simpler to do it this way, and also we would have massive problems coupling with the economic model on the other hand, because the economic model has also already values for money booked in, I can put it a little bit up. Oh, didn't do anything. Okay, so this is the bad color. Where's black? Yeah. So we have like this, like we have one sector which is called mining of copper. But we have this sector in 35 regions, right? So, and each of these regions has a share, like let's say China has 0.3% of the share of the monetary value of copper. US has like 20% or something like this. So the separation of this gets then translated into the economic terms, and then split up in the economic terms. So when you would try to model something like this, we don't do export trades with Russia in that case, yeah, like for gas, for example. Then you would switch the export shares and the trading shares to zero. And that would have an effect on the demand and also would affect the price in the other trends, because this commodity is not tradable for Russia in that sense. And we can not we can have the extraction, but it will be probably not tracked because it's burned in that sense. That's how we try to capture it. There's room for improvement, but that is a very complex issue. That's how it is solved in the moment. More questions? Or should I continue? No questions, continue. Okay, as you can see, the complexity of the model is more, like we have more different details that you didn't model in the other ones. Another one is like we model here. We compare, yeah. So here in this sector of this section of the model, we calculate the energy demand for mining. And of course, the energy is different according to different kinds of ore qualities, and also if we recycle or if we not recycle. So if we calculate the total energy need from the mining sector bottom up. Then we do the similar thing a little bit up. We do a similar thing here, yeah, for the water needs compared to the different kinds of mining ore grades, and also compared to recycling to primary extraction. We are not quite sure yet how we link this to the water model, but this one will be linked to the energy requirements of that sector. So that will be feeding into the economy and energy model again. Now I just want to show you, can you, this one? We have also, like, this is an oil model that is like our new oil model, and I did some test runs to show you some of the, or like how the feedbacks work in this model. So this is modeled a little bit differently than the copper model. Here you have still like the hidden and the known, but we don't have the separation in the different ore grades. We had it before, but due to some issues we had with the old ones that was not running in the same time step, which is a problem in system dynamics modeling. We got a lot of escalations. We needed to change the model structure and do something new. But you can see here we have some other advanced features that how we determined the productivity and how we determined how much oil is extracted. We did a correlation between the prices of oil and the drillings that were undertaken in the world. So like if the oil price was high, we looked at data, how much drilling, now new oil wells got opened. And then we tracked the number of operating wells, and then we have kind of a well productivity per well, which we averaged. That is not the optimal solution. Usually, like when a well is running longer, it should deplete. And that is something that we still want to improve. But also something that we considered here is like we took care of the OPEC spare capacity, because the OPEC countries are having a strong influence on the oil market. What do? So if they are not satisfied with the oil price, because the oil price is too low, they take oil from the market. And if they are sufficiently satisfied with the market, they have lower reserves, like they flood the market more. And especially, like we saw some trends, it was very difficult to model because sometimes they didn't behave, I would say, rationally. They just behaved out of political reasons in that sense when fracking came into place in the US, for example, because then the oil price was high, but they didn't want that the fracking gets more established, so they flooded the market anyway, even though it was not necessary. But we still were able to model this behavior, and then we have like identified like a desired target price, which is also part of the function. And we modeled the oil price in relation to what is taken away from the OPEC OPEC spare capacity and the supply and demand. So like the tension between supply and demand. So therefore we use the oil price and the amount supplied and the amount demanded, and developed a logarithmic function which was able to track the oil price very well. So now I want to show you some feedbacks here. Can you show the last 3 runs on the graph? So the green line, the green line is the model running with historical data. And that is the same curve that you saw earlier this morning when I showed you the price correlation with the historical price. I don't have the historical price right now plotted here, because it's a little bit more handiwork to do it now, but it is the same price curve. And what we did there is like we use the historical demand, we can replicate the price, we can replicate the extraction amounts and the oil available in the world. What we see then is, what I want to show you is like one of the feedbacks. So we play this scenario. Here's like a similar structure for the price structure that we implemented into the copper model, translating the oil price per barrel into this economic terms, like of it is 100 in the beginning years, and then it is rising when the price is changing and the tension is higher. So what we did here is like I did a little experiment and just to demonstrate the feedbacks and what kind of implications it can have on the economy. I introduced this yellow little variable here, which is an oil lookup price function. So assume it as a scenario parameter. Say like we don't want oil in our economy anymore, but we don't have another solution yet. So we just don't want it anymore, and we artificially raised the price. Like we said, like okay, we taxed it by now it's 3 times more expensive than it is before. So what is happening with the what will be happening with the economy? Output real? Energy. GDP, where was GDP again? In output real, right?
Output real.
So this is just plotting one country, and I will take the base run. Oh, wenn zum Joint
You want both.
Yeah, I just want to show the effect.
Which way?
This is UMC oil increase, and then we have this is the base one. Okay, this is good enough. So like here you can see like when the model is running with no changes in demand and nothing, like it's just running with the base data. So that would be the baseline without the scenario implemented or without calibration. That is the issue with the model. That's why we cannot, we cannot show all the implications yet because we need to calibrate it. But here you have like you see for UMCA, like for the region UMCA. You can see that like in the base run, the GDP is more or less stable, right? But here, when we have the same run over the same time and we increase the oil price by a lot, then we can see that the GDP is decreasing. Why is that happening? Because like the consumers, that will be also part of the effects tomorrow in the economy. Like the consumers cannot sustain this high price. Every product gets more expensive. That's actually what we see now with many cases. That we see that we have rising food costs, we have rising costs in heating, we have rising costs in all these kind of things, because everything is still linked to the fossil fuels at the economy in the moment how it is. But we can see that the feedback link is working in that sense. It's not calibrated, it's not the correct amounts yet, but that's how we tested the feedbacks. The same as going when we put on a supply constraint, then we would see it from a different angle. So when I would say like, okay, we reduce the production in the output of gold coins that you had, and we reduce the production, then our price would increase and would also affect the economy. Okay. Energy. Yeah, we're not going to energy. I think it doesn't matter. We'll just show this. Yeah. So I just want to finish with 3 little things. It's just like recent headlines to show the relevance of the model that we have, like, and what kind of implications we build, and then that we see things that we have in the model also in reality happening in the model. So it's in German, I apologize, I read German newspaper, but so like the extreme gas prices are reducing the DAX. The DAX is like a conglomerate of German companies on the stock market. So it is like decreasing the value of these companies traded on the stock market. Then next. So here's the other feedback that we mentioned and that we integrated into the model. This is like the oil producing countries want to reduce their production this year the first time. And why? The biggest exporting oil production countries want to reduce the production because because of the lowering oil prices. So the OPEC countries take oil from the market because the price of oil is getting lower. So we have that also in our model as well. Then we see something like this. So with rising energy prices, why is the GDP decreasing? So that's what I tried to show you with the oil example. It has to be also shown with the gas example and with the coal example, but we need to, as we said, calibrate and finish our model and our job to do this properly. But what we can see here is like the first companies in Germany are facing closure because of the rising energy prices. They're not able to compete anymore in the market, and they can go out of business because they're not able to pay the energy bills, which has a negative implication on the GDP, because that will increase the unemployment and unsatisfaction as well, and also have other economic effects that we will see triggering down. And for today, I think it's enough at least. But everybody who wants to stay and still finish the model is welcome to do that. And if you have any more questions regarding the materials model, you can ask me. We can go through it in detail. I can send you, like most of the materials model are also published in papers already. So I can give you a list with the papers where they are published. And tomorrow with Inaki together, or on Monday, if there's topics arising against because of the feedbacks, we can have a discussion about it. Thank you very much for today.
Thank you.